Today we are going to show you the measurement of an RFID tag, the backscattering effect of an RFID tag through a vector signal generator and an oscilloscope. So what we do here basically, we are using a vector signal generator instead of an RFID reader in order to send a fixed signal in a certain frequency and a certain power level to send it to the transmitting antenna, and from the transmitting antenna we are sending the signal to, you see this is an RFID tag, we attach it to a piece of wood so that we keep it far distance from the transmitting antenna, and then from this transmitting antenna the signal that will go here, it will be reflected back with its own information and it will come to a receiving antenna. And from the receiving antenna we can see here it is connected to an oscilloscope, the Rode George RTO 1022 oscilloscope. It can read the frequency within 2 GHz and it can read at 10 gigasample per second maximum. So here we give a signal of 866.6 megahertz frequency, and we found that within this frequency the tag responds better than any other frequency in UHF frequency range, which is actually 860 megahertz to 960 megahertz. So we started varying the frequency from 860 and then we go up and up and up, and then we found that this antenna, which is mounted to a piece of wooden slot, so this antenna has the frequency range of 870 to 960. So as we expected, that frequency of 866.6 megahertz is the nearest frequency range that it can detect the signal. The tag can detect the signal. So then we come to the power. So we started from 0 dBm. We give the signal and then we start reading. So we get for approximately 3 dBm. We cannot see that much clear signal, so we start increasing and increasing and increasing. So we found that for 15 dBm we get a better signal at the oscilloscope. So here at channel 1 we can see the signal that is going from the vector signal generator to the splitter, and then from the splitter it's splitting the signal in two directions. One is directly going to the transmitting antenna, one is going to the channel 1 of the oscilloscope. So we see that at the channel 1 of the oscilloscope the signal that is coming from the vector signal generator, which is a baseband signal. And another thing I have to tell you, that this vector signal generator is connected with the oscilloscope by an external trigger, so that we can synchronize the frequency and the voltage as well when we read. So as we measure before this setup, we measure by through a power meter, that when we give 15 dBm of power to the oscilloscope or to the transmitting antenna, basically after the splitter has 3 dBm loss, it shows us more or less 10.6 dBm. So we are getting 10.6 dBm to the transmitting antenna, at the same time 10.6 dBm at the oscilloscope. So this is the signal for 10.6 dBm that you are watching here. So this is basically the signal of channel 1 for 15 dBm. And then when we put channel 2 here, so we can see that okay, this is the signal that is going from the vector signal generator. I mean, it's the readers or vector generators own signal for that certain frequency range and certain power level, the programmed signal. And this is basically the backscatter. We will show you how it is, because if we take out the tag here a far distance, then we will see here there is no tag response at all. And then again, if we put this here, then we see okay, now we can see that a certain backscattering is visible. So now we are going to subtract the channel 2, which is the signal, along with the backscatter from the channel 1, which is only the signal that is coming from the signal generator, and then we can get the backscattering value of an RFID tag. Thank you very much for watching this video.